Hello, my name is Lachlan McInnes, and this is my presentation on quasi-clone detection from Java bytecode. Code clones are problematic within software engineering as it leads to unwanted problems such as bugs propagating within a codebase or wasting memory within a system. It also goes against the standard practice of object-oriented programming. Code clones can be classified as 4 different types, ranging from copy and pasted to semantically similar. Java bytecode as well is the compiled code which can be read by the Java virtual machine. The hope of this study is that by using instructions read by computers instead of human written source code, we are able to better identify code clones than current research. If we are successful in understanding how to identify code clones within bytecode, it will be a step forward in the space of code maintainability and performance. Current methods within research generally utilize source code to identify code clones. Furthermore, there are many methods of string pattern matching which are yet to be implemented in the area of code clone detection. The scope of the work attempts to answer the research questions. Is the Marzell distance formula better than a simple normalization method when detecting code clones? Does normalizing the instruction codes for Needleman-Wunsch algorithm impact the detection of code clones? And is the Needleman-Wunsch algorithm a suitable O of n squared time complexity method for identified code clones up to type 3? This alters from previous studies investigating either longest common subsequences or Smith-Waterman algorithms as they look at local clones within a class or method instead of global ones. Throughout the report, we effectively discuss background information required to understand the problem, current research in the area of code clone detection, and gaps in the literature. We were also able to use a new tool developed with the Needleman-Wunsch algorithm on bytecode to detect code clones. This included the raw bytecode as well as the normalized. We were also able to test this against a current state-of-the-art tool called NiCad and see the differences in code clone detection on state-of-the-art benchmark known as Stubber, a bytecode form of the Big Clone Bench database. When looking at recall, the post-normalization dissimilarity measure provided the best results. Furthermore, as the lines of code decreased, our tool performed worse than the benchmark, NiCad. It also appears the Marzell tool is more conservative with what it believes similar code clones are. This can be shown in column 10 min lines and row 70% similarity, where we see that we achieve in finding all the code clones in the buckets between 80 and 85%. However, when looking at row 80% similarity, we see that we only detect a minimal amount of these 80% clones. Therefore, we can assume that this has been found, but has been given a lower classification in terms of similarity. Finally, by reviewing 50 code samples, we established that the normalized opcode Marzell edit distance had by far the best precision. To the right, we can see the final F measure scores for each tool within each scenario. As can be clearly seen, the normalized opcode Marzell edit distance provided the best detection for identifying code clones. Furthermore, when analyzing the data further, we saw that there was a correlation between the difference in lines of code and the associated difference in number of instructions at the bytecode level and our tool's effectiveness to detect clones. This can be shown by the below formula. For future work, we will need to investigate automating parts of calculating precision of code clones and release to researchers in this area. Furthermore, we need to optimize time complexity of the Needleman-Wunsch algorithm to suit the needs of code clone detection. We need to also investigate clustering outputs similar to NiCad so that researchers are able to evaluate outcomes easier. And finally, investigate if there is in fact a correlation between ratio of lines versus instruction length and its impact on detecting similarity.